So studying reaction rates, we learned that reaction rates generally increase with increasing reactant concentration, right? So for this reaction, if we increase the hydrogen concentration or increase the iodine concentration, the reaction is going to go faster, right? In a reversible reaction, the reaction can proceed forwards and backwards. As these reactants react, their concentrations go down and the rate of the forward reaction slows down. Well, as these react, we're forming product, meaning that the product concentration is going up. Well, the product is the reactant for the reverse reaction. So if this goes up, then the reverse reaction speeds up. Does that make sense? So let's look at an illustration of this. So here we have hydrogen and iodine reacting to form, hi! Initially, we just have our reactants. And down here we have a graph that's showing us concentration increasing as we go up versus time. So initially, when this starts, we have a high concentration of hydrogen and a high concentration of iodine, and we have no HI. So as these guys start to react, their concentrations go down, and the high concentration goes up. Does that make sense? So the rate of the forward reaction is going to get slower and slower. The rate of the reverse reaction is going to get higher and higher. At some point, those rates are going to be the same. And so we have forward reaction and reverse reaction happening at the same rate, and the result is that now the concentrations are not changing. They're staying the same. Does that mean that nothing is happening? No, it doesn't. There's a lot of stuff going on down there. There's forward reaction and reverse reaction. But they're kind of canceling each other out. And so we reach dynamic equilibrium and the concentrations stay the same. Any questions? So, dynamic equilibrium, condition in which the rate of the forward reaction equals the rate of the reverse reaction. Both reactions are still happening. The concentrations are no longer changing. But this is important. They are not equal to one another. Is it possible that they would be equal? It's possible, but that almost never happens. The rates are equal, the concentrations are not equal. The relative concentrations depend on the value of the equilibrium constant, which is going to be different for every chemical reaction. Any questions? So we have sort of a population analogy. In an earlier edition of the textbook, A, the rates of the forward and reverse reactions are equal. B, the concentrations of the reactants and products are constant. C, the concentrations of the reactants and products are equal. We're looking for the one that's not true. It's going to be C. The concentrations of reactants and products are going to be constant at equilibrium. They're not going to be changing, but they're not going to be equal. Okay? Forward and reverse rates being equal, that's like the definition of equilibrium. Any questions?